Hello, my name is Brian Lang, and my group consists of Adam bin Iskandar, Jeremy Winro Anajerio, and Muhammad Hafizur Rahman. So the title of our assignment is Manufacturing of a Continuous Line of Salbutamol Tablets through the methodology of DMADV. So the design for our Six Sigma, which is mentioned previously, is based on the DMADV methodology. So DMADV stands for Define, Measure, Analysis, Design, and Verify. So our chosen product is salbutamol tablets. Basically, chemical engineers like us plays a crucial role in designing and operating large-scale pharmaceutical production facilities to ensure a consistent quality, safety, and compliance with regulations. They optimize production processes, manage equipment, and oversee regulatory adherence. So, given the high prevalence of asthma based on the data from World Health Organization, it suggests that there is around 262 million people are affected. So basically, this study, which is to optimize the process of continuous manufacturing of salbutamol tablet, is crucial as it benefits the overall society. This study focused on developing a design based on the wet granulation process, a popular choice in pharmaceutical manufacturing. So the problem statement is batch process. Batch process require quality and uniformity testing for each batch, leading to downtime, recalibration between batches, higher storage costs, and increased risk of contamination. So by proposing a continuous manufacturing, it helps the process to be more productive as there is always a production line running, making the process more time efficient. However, the production of salbutamol tablet still rely on batch manufacturing. As we move on to the scope of the case study, the author wants to visualize the critical parameters of each unit through a CTQ, critical to quality tree diagram, as well as the Pareto diagram. And then from that from the diagram itself, we can develop an optimized design for a continuous line of salbutamol tablets production through experimental design methodology. And lastly, we can verify through a surveillance system the automated forward and backward loops using control charts. So starting with the first phase of DMADV, which is the define step. Define step, basically we want to know what are the customer needs. It is to understand the customer needs and desires with particular attention to the voice of the customer. So we define a set of parameters like the stability, the packaging, so any kind of this quality where we get feedback from our customer, like customers example like clinic, pharmacy, hospitals. So what are they looking for particularly in our salbutamol tablets? So once we know quality we need to improve, we can list down all this quality and then we can set a matrix. Next is the CTQ diagram. So this critical to quality tree diagram basically shows a hierarchy of the quality aspect, uh, where the quality aspect branches down into several parts to make sure the quality of the salbutamol tablets is meet the consumer demands. So for a high quality salbutamol tablets, it has four quality aspects that need to be controlled, which is the performance characteristics, potency, accurate dosage per tablets, as well as the consistent active ingredient distribution. So under the performance characteristic, the production engineer to make sure that this integration time and tablet must dissolve with specific time as well as the stability of the tablet. It also branches down into a long shelf life, resistance to environmental factor, tablet compression force, and tablet weight. So these are the small aspect of the quality control which can be improved through the performance characteristic. Another one is potency. So potency branches down into three quality aspects, which is the tablet thickness, coating solution concentration. So when we try to improve this quality, we can uh, adjust these three parameters. We can measure and control these three parameters. Another one is accurate dosage per tablet. So there's a three quality aspect here also, which is the spray rate, drying temperature, and packaging. And lastly is the consistent active ingredient distribution, which is affected by the seal integrity, labeling accuracy, and packaging material quality.
So we move on to the measuring stage where we measure and identify critical to quality characteristics of the product, service, or the process. And in this case, we are finding the characteristics of the process or the parameters. So the first step will be the data collection. A data collecting plan was created by compiling details from earlier research and publication about the methods used in pharmaceutical business and the promotion of salbutamol tablets. And then the measurement system was created where the Minitab software was used to create a measurement strategy and a measurement system analysis. Then next will be the measuring of parameters. Following the identification of the critical parameters, a Pareto chart will be created in order to quantify these parameters. Then the Pareto chart will be shown in the analysis section where it will be explained more.
Hi, my name is Mohammad Hafizur Rahman and I will be explaining for the analyze part. In this article, they apply the Ishikawa and Pareto chart for further analysis to find the main causes and critical parameters that affect the production. So in this continuous production of salbutamol tablet, the Ishikawa diagram was used to identify potential causes of variability in critical quality. So the team used categorized based on the plant, drying, wet granulation, analytical, and others to structure the analysis. As you can see here, there are five bonds which are the plant, drying, others, analytical, and wet granulation, which each branch consists of the causes of each category. For example, plant there are temperature, operator, machine, and training. For drying there are temperature, airflow, and shock cycle. And for others there are lubricant, diluents, and etc. For analytical method sampling, and for wet granulation there are power, time mixer, chopper speed, spray lead, and etc. So they use the diagram to drill down into each cause looking for root causes. So further analysis will be made to find which category have the most effect on the production efficiency. After conducting an analysis using the Ishikawa diagram to explore the various factors influencing the continuous production line of salbutamol tablets, the decision was made to prioritize the wet granulation category. Subsequently, through the application of the Pareto chart, a focused examination revealed that only four critical factors, including temperature, mixer speeds, chopper speed, and time, were identified as the most significant contributors to the production process efficiency and quality, as shown in the Pareto chart of the standardized effects. So the manipulation of this data is significant to the model and simulate the behavior of process components and variables. These factors are crucial for optimizing production efficiency and quality. So from these four parameters, it is will be used in the design phase and will be optimized using the RSM method, which will be further explained later on. So to explain a little about this Pareto chart, the interaction between the temperature A and B, AB, has the most significant impact on the production. This means that changes in the production are significantly affected by the combination of these factors. While individual factors like temperature A show a considerable effect, they do not meet the threshold for statistical significance independently. The other factors and interaction, although they have some effect, are not statistically statistically significant in this analysis.
So for the design stages, the stages focus on the analysis and the optimization of the critical parameters, which are the temperature, mixer speed, chopper speed, and the time. So in the Six Sigma process, the optimization stage is usually the most time-consuming process, which require us to collect relevant experimental data and analyze them. In this case, we use the response surface method for the optimization, where the comparison of two processes were made for both the batch and continuous process. After developing the response surface model, the RSM is used to find the optimal setting for the process parameters. And then, as you can see in the figures, it display the surface graph that illustrate the temperature and mixer speed and also the chopper speed and how they significantly impact the continuous production as seen at different time points, which are 6 hours and 10 hours. Overall, the findings show that the best parameters for producing salbutamol tablet in a continuous line using the wet granulation method are an 85 degrees Celsius temperature, 630 nanometer mixer speeds, 250 nanometer chopper speed, and a 10-hour duration. These parameters assure both high quality final products and an effective production.
In this section is the verification for the DMADV process. So our goal is to achieve a desired control of critical parameters in each unit, and the method we use is the X bar chart. So the control limit was obtained based on data analysis from the Pareto chart and design of experiment. So based from this X chart, it was found that over 30 critical data points available in the process. It was determined that everything is stable and that no control point exceeds established limit. The process is under statistical control and the process is functioning consistently and producing quality product.
So, based on the article, conclusion can be made, which is the one major limitation of this project was the inability to modify the product formula as it is related to the pharmaceutical industry. Second one is the project focused solely on optimizing the production process. This, Despite this limitation, the result of the achieved production time in a continuous process. The design of the continuous process for salbutamol tablet production is a significant contribution to the pharmaceutical industry. It is it not only improves production times but also reduces losses due to imperfection and lowers hiring costs. It provides a social benefit to users of this pharmaceutical and serves as a valuable reference for researchers and professionals considering the implementation of a continuous manufacturing process using DMAF. Researchers are encouraged to adopt this process and design in production plants to measure and compare its results, further validating its effectiveness and potentially enhancing the production efficiency and quality in the pharmaceutical industry. That's all from my part. Thank you.
For the personal reflection, based on the case study, our group had learned the value of DMADV as a tool for the innovation of a product, or which in this case is the process design for manufacturing salbutamol tablets. Implementing DMADV early can be more economical than making changes after production begins. This is because it offers multiple benefits including reducing issues in manufacturing, assembly, service, and support. The case study highlights how DMADV can be used to improve the salbutamol tablet production, which can potentially benefit many people in the future due to it being used as a relief for all types of bronchospasm illness. The more efficient production process can lead to increased distribution of these life-saving tablets. Thank you very much.